Okay.
Okay, so I will share my screen and we will just walk through this last function a little bit slower and unpack it. But a lot of this is very similar to what we've already talked through. This now just puts it back together. And I have this function here that takes the value that we're trying to test. So we have any type of sample. We have this variance of the hypothesis that we're trying to test. And I wrote this type of function so that could either take a two-tailed test, a lower or an upper. And so similar to the function that was posted on the homework channel earlier today about can you use this proportion for the last class's homework? And it had some of these input parameters to the function that you can find online through Python's other packages. This is just writing my own function that would execute something similar that you might find in the stats package. So I would assume it exists out there. This is just one that I wrote that brings all the pieces together, and it will actually then test the hypothesis depending on what you input to it. So I bring that up just if you do find something else online that's not this, because there is one out there, just make sure when you're testing it that you have this direction defined. And if you do use this one, this kind of just shows the differences that you might expect. So let's walk through it, where we have the number of observations. This creates the value of our test statistic, where this is that null hypothesis of what we would expect to have, where this one we were testing in this example is the standard deviation of returns for the value fund different than 15%. So we would need to take the variance in order for us to use our formula rather than standard deviation. So we take the square of this standard deviation and get 225, which is what we're trying to test for. And that is why this is our expected variance here. And we have our sample standard deviation, which is what we use as this value of X. Actually, we don't even need to put that here. We just need that. This does it all for you, actually. Because this one takes the variance of it and divides it by what we're expecting. So this just takes the formula from the textbook that we walked through, and we'll create that test statistic for you. And it prints what that test statistic is to be 48 here. And it uses the distribution under the curve where this same PPF, the percent point function, gives us that exact value that we would expect to see. And so if this is lower, let's say we were trying to test something being below the value. So I didn't even define it here because the default would be two-tailed. But if I were to have defined the direction, which it's always good to be more explicit, I would say two-tailed. But if we were to reapply this function and we wanted to do lower, I would define lower here. Or if I wanted it to be upper, we're now using more of Python to build a robust little toolkit for us to calculate if it's upper or lower. But the default will be this else function, which that is the default of the direction being two-tailed. So that's why, since I didn't define anything, it just went to that one. But if I wanted to be more explicit, I can even just to show you, sometimes it's good for troubleshooting to just be this logic hit. So I'm not, when you're troubleshooting things, it's good to know where did the input parameter go. So my assumption is that it's going to hit this print statement. So we see that it did, where it first calculated the test statistic here using this formula that we have. And then because it was a two-tailed, it took the lower and upper bound using the different formulas. And if the value was less than or equal to one of these different values, we would have more evidence to reject the hypothesis, reject the null hypothesis. But if it is within this interval, we fail to reject the null hypothesis. So that's why this test statistic was 48, and it was within our lower and upper bound. Therefore, we do not reject the null hypothesis because the value was between these lower and upper bound. And that's what this writes right below. Any questions on this?
Not off the top of my head, no. It's just, it looks like a lot because that like whole thing is like large, but it's useful. So it makes sense why you have it like that.
Yeah, let me chunk it a little bit because we really, if we didn't want this to be so robust, we would just have to use it in different ways and manipulate it more. So this just tests for one tail lower. But yeah, I agree. It is a lot here, but it kind of, goes to show once you have this coding tool, you can start to build more robust tools for yourself. And you can do similar stuff like this in R as well.
What's R?
Oh, R Studio is, I assume, in the next class for the MBA program that they use R Studio rather than Python.
Oh.
And it is similar in how it has a lot of statistics packages, and essentially you can do a lot of the same stuff in R. And I would definitely say if you're interested in like comparing the differences between R and Python, that there's lots more research out there that would do a better job than my own perspective on it. But from what I've seen more in the industry, Python's used compared to in academia. A lot of times R is used. And the reason why I chose Python is having all of this like Colab, you don't have to install anything, and all of these other things that are built around Python that are probably also built for R. But just if you're using any of this in a professional setting, Python would be very useful. So that's why I chose it. There's a lot that's built around Python that is probably also built in R, but I think like the community behind Python, this is again my own bias that I prefer Python because of the community around it and how many things are built for it, but I'm sure it's also built for R. So I think like the most specific difference is how it's used in the industry. And I think the user-friendly aspect of using Colab and having Markdown and all the things around it.
All right. Well, I'll see you when I get there, I guess.
Okay, sounds good. All right, so I will stop the share and stop recording.